Hello students, so now we are on our next topic of the chemistry in the series of structure of atom. Now we are on our next topic. Our next topic is atomic structure and electronic configuration. Atomic structure and electronic configuration. So, our next topic after the models of an atom are atomic structure and electronic configuration. Now we will discuss these both topics one by one. So, our first topic is about the atomic structure. So, we have learned that in an atom, it majorly consists of electron, proton and neutron. These are the subatomic particles of an atom. So, atomic structure will be studied in two different categories. That is, first is nucleus and the second one is extranuclear region. So, atomic structure is broadly classified into two categories, that is, first one is nucleus and second is extranuclear region. In the atomic model of an atom, we have studied that the whole positive mass of the nucleus is accommodated at the center. It means the nucleus consists of neutrons and protons, and in the outermost shell, the electrons will going to revolve around it. So, if I considered an atom, what we see here is the positive charge is embedded at the center and the negative charge will going to revolve around the outermost shell. It means this positive charge is enclosed in the center of the nucleus and the negative charge will going to revolve in the orbits of the prescribed energy. So, here the positive charge sphere we have discussed is nucleus. It means nucleus is basically made up of protons and neutrons, but protons are actually the positive charge and neutrons is having zero charge. It means the entire mass of nucleus will be judged on the basis of only positive charge, or we may say that the nucleus is a ball or a mass of only positive charge. So, nucleus is a sphere of positive charge. So, here are some of the basic points about nucleus, that it consists of the positive charge which is embedded at the center of the nucleus, and we say that protons and neutrons together constitute the nucleus. So, protons plus neutrons, we may collectively call these termed as nucleons. So, protons and neutrons together are termed as nucleons. Neutrons is having a no charge, so the entire mass of the nucleus will be according to the protons. Now, the term nucleus is completed here. Now, we are on our second term, that is about the extranuclear region. After surrounding from the nucleus, we have a region around the nucleus, that is here. This part is called nucleus. This part we have is called nucleus, and the region except nucleus here, this region is known as extranuclear region. So, this region is extranuclear region. So what will happen in this extranuclear region? We see here that electrons will going to revolve around the in extranuclear region, and the path in which electron will revolve is known as orbit, and we may also say that the orbits will have a certain energy levels. So electron will move in a path and this path is known as orbit, and we may say that these are the energy levels. So we will write about the extranuclear region. So now after nucleus, we will on our next topic, that is extranuclear region. Extranuclear region is the region in which the electron will going to revolve. So we are on our next term, that is extranuclear region. Extranuclear region is the area in which electron will revolve. So in extranuclear regions, electron will revolve around the positive sphere, and the positive sphere we have called it as a nucleus. Now the electrons will revolve in a certain specified path. So the path in which electron will going to revolve is known as orbit. We may also call it as a energy shells in which the electron will revolve. Now in the extranuclear region, we may see that orbits have some sort of shells in which electron revolve. These shells are further classified into subshells. So electron will revolve in shells, and these are shells are actually the energy levels. So we can calculate the number of shells can be the formula for calculating the maximum number of shells will be 2n square. So maximum number of shells can be calculated by using the formula, that is 2n square, and shells are designated by the symbol K, L, M and N. So shells will be designated by the symbol we have four symbols for the shell, that is K, L, M and N. So here are the four shells in which electron will going to revolve, and the formula for calculating the maximum number of electrons in these shells will be 2n square. So now we will see how many electrons will be embedded in one shell. If someone wants to copy it, please copy it. Now we will calculate the maximum number of electrons in a particular shell. So firstly we will write name of shell. Here we will write value of n. Here we will calculate maximum number of electrons. So in this shells, we will calculate the maximum number of electrons that can be accommodated by K, L, M and N shell. So firstly, we will write the name of the shells. The name of the shell will be K, L, M and N. As we have 4 shells, then we will write their number of specification, that is 1, 2, 3 and 4. Now we will calculate the maximum number of electrons that can be embedded in these 4 shells. So calculation for maximum number of electrons will be 2n square. So what we will done here, we will calculate the maximum number of electrons, that is 2 into 1 square, we will get 2. Again we will have 2 into 2 square, we will get 8. In the third step we have 2 into 3 square, we will get 18. In the fourth shell, that is M, N shell, we will get 2 into 4 square, that is equal to 32. So these will tell us about the maximum number of electrons that can be prescribed in a particular shell. So in K shell, we can have 2 electrons. In L, we have 8 electrons. In M shell, we have 18 electrons. And in N shell, we have 32 electrons. So we have 2, 8, 18 and 32 maximum electrons can be prescribed in K, L, M, N shell. So it is about K shell, L shell, M and N. So it is how we will distribute the atoms accordingly to the formula, that is 2n square. Now shells are further divided into a category, and this category is known as subshell. So we have next topic about subshells. It means shells are further divided into subshells, and we have 4 subshells here. These subshells are S, P, D and F. These are the 4 shells which will accommodate a maximum number of electrons according to their shells. So we have 4 shells S, P, D and F, and these can be written as S means, so now we have 4 shells, that is S for sharp, P means principal, D means degenerate, and F means fundamental. So these are the recognitions for S, P, D and F orbital. So first is sharp, second is principal, third is degenerate, and F means fundamentals. Now we have discussed that we have 4 shells. The 4 shells are K, L, M and N. In these 4 shells, we have further category that is called subshells. In this subshells, in K we have S, for L we have S and P, S, P and D. So shells are further classified into subcategory that is called subshell. In K we will having a S shell, and in L we having SP, SPD and SPDF. So S shell can accommodate maximum of 2 electrons, S and P will 8, 18 and 32. So we have 2 electrons in the S shell, 8 electrons in S and P subshell. SPD will having a 18 electrons and maximum electrons will be 32. So here is a category of shells and subshells. Now subshells are further divided into a term that is called orbital. Now again, subshells are divided into orbitals. So what actually the orbitals are? Orbitals are the three-dimensional structure in the nuclear region where the tendency to find an electron is maximum. So what are orbitals? Orbitals are actually 3D structures. These are 3D structures in which there is a tendency to find maximum electron. And the maximum electron that is present in any orbital will be 2. So again we have 4 shells K, L, M and N. We have 4 subshells that is SPDF, and SPDF is further categorized into a category that is called orbital. So we have a formula for calculating maximum number of orbitals, and it can be calculated as n square. So this is a basic formula for calculating the number of orbitals over here. Now we have 4 shells K, L, M and N. Now we will take the value of N. It is 1, 3, 5, 7. Now we are going to calculate the orbitals. So the orbitals will be 2, 6, 10 and 14. So these are the basic orbitals in the electronic configuration of an atom. Firstly we have taken shells that is K, L, M and then we divided into subshells that is SPDF. Now we have a term that is called orbital which can accommodate a maximum number of electrons. So orbit is a path in which the electron will revolve, and orbital is a 3D structure in which there is a capability to find maximum number of electrons. Now it is necessary to calculate the number of electrons to write the electronic configuration of an atom. If an electron consists of 2 in an orbit, we will say that it is called duplet. If it contains 8 electrons in the outermost shell, we will call it as a octet. So if it constitute 2 electrons, we may use the term duplet. So it may constitute 2 electrons. But if there is a tendency of 8 electrons in outermost shell, we may call it as octet. Octet means it can accommodate 8 electrons. Duplet means it has a tendency to accommodate only 2 electrons. So students, we have talked about shells, subshells and the orbitals. We have calculated the shells as K, L, M, N. Here N will represent the number of orbitals. There is a little correction here. And it will count the maximum number of electrons. So we have electrons. So number of orbitals can be calculated by the formula n square. So we have 1, 3, 5, 7, that is the orbitals, which will be in the odd number. And if we want to calculate the electrons in it, again we will use the formula, that is 2n. So it will have the double electrons in each orbital, and each orbital will carry only maximum of 2 electrons. So for n shell, I am writing the formula here. For n shell, we have orbital 7 and it can accommodate maximum 14 electrons. So it is all about the shell, subshell and orbitals. Now we will on our next topic, that what is the actual difference between orbit and orbital and how will we write the electronic configuration of a particular atom. This topic will be discussed in our next class, and this lecture is over for today. Thank you so much and have a nice day.